So we're going to talk about cycling of matter. We're going to talk just briefly about 3 different cycles. You're gonna have videos on all these too. So I'm gonna give you a little information, then you're gonna watch some short videos and then answer some questions. But the first one is on the oxygen cycle, and this has 2 processes: photosynthesis and cell respiration. I know we didn't talk a lot about this. This is one of the things we lost out with our distance learning. But photosynthesis is how plants get food, and when they do that, they release oxygen. But also, you can see this arrows going into the tree. They absorb CO2 for us, which is a good thing. We'll talk about that in a little bit again. But then we eat plants, or whatever food we eat, we break it down. But when we eat food, it produces CO2, which is toxic for our body. So we have to get rid of that CO2 somehow. So as we break down the food, that CO2 is then released into the air every time we respire. So when we breathe, we give off CO2. So we give off the CO2, plants absorb the CO2, give off the oxygen, which then we breathe in. So we have a cycle that's there. The second cycle is water cycle. We're going to remember this with Procida. This is kind of a review. You know the first 4 letters there. The last 3 are probably new. So P, easy, precipitation. We can see that in the drawing. R would be runoff, so anywhere it runs off. E is evaporation. So the process of evaporation, you can see in 2 places here, is going to go from a liquid, here on the bottom, changes to a vapor. And then C goes along right with that. That is condensation. So as it becomes a vapor, it then condenses, again, like around dust or salt, to make those water droplets, condenses into water droplets, and they condense around a piece of dust. And when they get big enough, we see it as a cloud. So we have condensation, that's going to make the clouds. The last 3, ITA, I stands for infiltration. Fancy word here, just means it soaks into the ground. T is transpiration. So every plant transpires, which means it releases more water vapor into the air. It's a good thing. And then A is absorption, and on my picture here, it's plant uptake, but I'll write that here. So it infiltrates or percolates is the same thing, but then the plants are going to absorb it. That's needed because plants are all doing photosynthesis, and they have to have a source of water to do photosynthesis. So there's our basic thing. Why do we worry about water in North Dakota? So I know we're not the land of 10,000 lakes, but we do have some issues that we worry about in North Dakota, and specifically West Fargo. So where do we used to get our water? Aquifers, which are wells. And those wells were treated with 2 things. It was super easy and cheap to run because it only was treated with fluoride, which is for your teeth, and chlorine. Think of what that would be, to get rid of the bacteria, make sure it was safe for us. The problem was it was really hard water, and we complained, and we said we didn't really like the way it tasted. So in the last couple of years, we have partnered with Fargo, and we now have a city. We get the water treatment plant water from Fargo, so it pipes it over to West Fargo. So all of our water is coming from the water treatment plant. We like that. We said it tastes better. It's softened, so we're happy with that. And most larger cities do get water from a surface area, because the water in Fargo gets its water from the Red and the Cheyenne. So both places are piped into that water treatment plant. They clean it up, and then it's piped into our houses. We have this big lake called Devil's Lake, and this is a landlocked lake, which means that it doesn't have an inlet or an outlet. So it's like a big bathtub. So as it rains, it fills up with water, and then it evaporates, and then it sinks. For a while, we were having really wet periods of time, and that bathtub of Devil's Lake just was filling up and filling up, filling up, and we were really worried it was just going to spill over its edges, and that would have been a catastrophic flood. So they had to figure out what to do. But Devil's Lake drains into the Cheyenne River, which then drains into the Red River, which then drains into Canada. And Canada and Lake Winnipeg did not want this water. So it took a lot of work and effort to get this figured out, but we finally got these outlets there. So now there's a western outlet, which works by gravity. That's great because it's cheap. They just have to open it up, and then water just naturally flows into the Cheyenne. But at the time when it was really high, it wasn't fast enough, so now they have an eastern outlet, But this one doesn't work by gravity and has to be pumped out. So that means it costs money to run this. And it goes through Stump Lake, which has been really good for Stump Lake because that was kind of a lake that looked really bad too. And it's because there's a movement of water that naturally filters and cleans out that lake. So it's better for all the recreation that happens there. The issue that why nobody wanted this water, especially Canada, is because it's flooded farmland and it has lots of sulfates. And sulfates can upset stomachs, which you don't want to drink water and then get sick. So they had to take that sulfates out, which was really expensive, and water treatments had to add this all in. So they asked the federal government for money, but like Valley City takes water out of the Cheyenne, and the Cheyenne was getting the water from Devil's Lake, so I'd take that out. Fargo, same thing, had to add something to their water treatment plant. Grand Forks, same thing, so it was expensive. So here's a quick picture. You can see here's the West End outlet that works by gravity, and then here's Stump Lake. Here's the eastern one, and it is pumped out through that. So Stump Lake is benefiting from this. The other thing we worried about is we are making tons of money by drilling for oil. And the way the oil works is they have hydrologic fracking. Hydrologic meaning water is used to do that. So they have to drill down and then they can make a 90-degree turn. And this is all called shale rock. And that shale rock then has to be cracked or fractured. That's where you get fracking from. So they fracture the rock, but in order to frack it, it takes thousands of gallons of water, and they mix in that water a trade secret, which could involve gasoline, could involve benzene. We're not sure always what's being used in that. So the water is no longer drinkable. But it also has sand in it. So the way it works is then they explode it. So here you can see cracks right there. Those are all cracks in the shale. And then the sand is in this water that is exploded. And the sand gets lodged into these cracks and holds them open. And then, so what can happen is then the oil can now ooze out. So all of this fracked water that's here then is pumped back out. And then it's going to be stored somewhere. But all of that water is contaminated and we don't have a way to clean it up, so it just can be stored. It's not really safe for anyone. So we have two concerns, right? What to do with all of that water they're using to frack these these oil wells. And then the other one is, here is your water table. So here is where the water is, like you can see this house is getting water from that. So they have to line these pipes with cement, something to keep any of the oil or anything from leaking into the water table, because that wouldn't be good either. But these go like a mile deep, and then these can go out like 3 miles. So there's lots of oil that's there in North Dakota, and it's making us a ton of money, but we do have concerns about the thousands of gallons of water that's used. Okay, the third one is the carbon cycle. So anything that's burned, so every time we have a campfire, we are releasing CO2 into the atmosphere. So that's anything that is burned does that. And we could be, sometimes it's methane. Methane is CH4. And that, when it's in the atmosphere, mixes with the oxygen and then makes more CO2. So you can see a C here and a C here with oxygen. So methane also makes CO2. So where does the CO2 come from? One place is garbage. So every landfill that we have would have pipes in them, and they'd have like a little blue flame because they'd have to, every landfill as garbage breaks down is going to release methane, which then becomes CO2 in the atmosphere. And it takes a long time to break down all of that garbage. But so it used to be that Fargo would burn all this methane, but now it's capped these and it is sending that methane over to the Cargill plant in West Fargo, and they are using the methane to power or heat their plant, which actually the Cargill plant then is paying for that methane, and this is one way that the landfill actually makes money. So way to go, Fargo. The other thing that releases a ton amount of CO2 is cattle, because of course what they do is they have to break down grass, and it takes a long time to break down the grass that they're eating. And as they do that, and they have, they talk about chewing their cud and have their 7 stomachs, that they release a lot of methane gas. So a cow can belch and pass as much as 1,000 liters of gases per day. All of that goes in the atmosphere and makes CO2. Who would have thought? But it is a source of CO2 for the atmosphere. And some of this oil, every time oil is pumped out of the ground, it brings methane with it too. So again, there's more CH4 every time we drill for oil. Some of this is piped, but not all of it is. So if the methane can't be piped, then the only way you can get rid of it is to burn it. So, and these give off light, and they burn 24 hours a day. So all of that is CH4 that's burning at this drill. If you look at a satellite picture of, you can see North Dakota, it looks like we have lots of cities out west. That's not true. It's just methane gas that's being burned. So when we look at the CO2 cycle, we can see, like, here's a coal power plant. So every time it burns, it's going to release CO2 in the atmosphere. All of our houses are going to release CO2 because we have to use the coal to turn on our energy. And every time we turn on a light, we're going to release CO2. Every time we drive a car, we release CO2. Here's a forest fire that would release CO2. Here's our garbage truck, so it's going to end up in the landfill, which also can release CO2. Here's our car, that's going to release CO2. Here's our cows, they release methane, which becomes CO2. So we're releasing a lot of CO2. Plants, on the other hand, they're going to absorb CO2. And so when you just look at this, we can see that the cycle is not balanced. And so that's when we talk about global warming or climate change, because more CO2 is being released into the atmosphere than it's been taken in. So then we look at what are ways that we can do to reduce that amount. So we're saying, could we put more wind turbines in? Because that does not contribute to the CO2 cycle. We're number 1 in wind potential. It's always windy in North Dakota. Or making it profitable or inexpensive enough to put solar panels, although it's cloudy a lot in North Dakota, and that would not contribute to the CO2 cycle. So all of these things are looking at how matter is cycled in our environment. So those are the 3 cycles we're looking at this week.